Guys, welcome back to TechDose, and in this video we will look at the minimum number of changes to make binary string beautiful problem, which is from Leetcode number 2914. Let's now look at the problem statement. In this problem you are given a zero indexed binary string as having an even length. A string is beautiful if it is possible to partition it into one or more substrings such that each substring has an even length and each substring contains only ones or only zeros, and you can change any character in S from 0 to 1 or from 1 to 0. You need to return the minimum number of changes required to make the string S beautiful. Before looking at an example, let's look at the constraint. In this case, the string length is maximum 10 to the power of 5, so definitely an n square algorithm is not expected here. And you see S is always even. This is guaranteed. Fine. And since this is a binary string, you will always have zeros and ones. Now let's look at an example. In this case, let's say that our given string is 100 Now since the length of the string is always even, here I have taken a 6 length string. Our goal is to make the string beautiful with minimum operations, and the constraints are each substring contains only ones or zeros. Okay, it cannot contain a mix of ones and zeros. So here you can say that there are 4 substrings, right? There are 4 possible substrings which are already given. The first one is of odd length, second one even length, third one odd length, the fourth one even length, right? Now each substring should be even length, right? This should be present in our resultant string. Okay, in this case the given string does not have all the substring of even length. If they are already of even length, then your minimum operations will be 0, because you do not need to do any flip. Like if my input was 1100, then I do not need to do any flip because this is of even length, this substring is of even length. So it's fine. But then in our input, all of them are not of even length. Some substrings are odd length, right? One operation is equals to flipping a bit from either 0 to 1 or from 1 to 0. Okay, we need to use these operations, and we need to minimize the number of operations to convert all the given substrings to even length. Now in our case, in our input, we have 100. I can just flip these 2 bits 00 to 11, and I will get 4 ones and then 2 zeros, which are both of even length. And it is correct. We have done this in 2 operations. We cannot do in less than 2 operations if you try here. Another way to do it will be to convert this first one to 0 and this one to 0 as well. And then you get all zeros. This is of even length as well. So you can have multiple configurations, but we need to just return the minimum number of operations to make all the substrings of even length. And in this case, the minimum operation is 2, so our answer is 2. So I hope you have understood the problem statement. Now having understood this, let's look at some observation to solve this problem. Now this problem cannot be solved if the length of S is odd, but our problem statement already says it is of even length, so it is fine, right? Why this cannot be solved is, let's say you are given this even length string and this odd length substring. Now even if you make this odd length as even by flipping this 1 to, let's say, 0, then this leftover one will become odd length. And if you want to make it even length, then you have to make it 0, and then this will be of even length, but then all the count of zeros will be odd now, which is 5. So it is not possible to solve this problem if the entire length of the string is odd. So it has already been mentioned that the string length will always be even. Now the second point is a new substring only starts when a bit flips, right? You see this. If you start a substring with all ones, it should be all ones. As soon as you see a 0, that means the previous substring has ended. Now when you start a substring with 0, you will include all the bits into the same substring unless you see a bit which is different, a flipped bit, right? And this will be substring number 2. This is substring number 3, and this is substring number 4. Okay, I hope you have understood the idea of substrings. Now there are a few important observations to be made here. The first one is flipping a bit can change the odd to even substring length or an even to odd substring length by just flipping a single bit. Let's see. In our example, I have taken a 10 size string. The first substring here is of length 1. So this is an odd length. Now if you see this 00, which is beside the odd length string, then it is of even length. Now if you just flip this 0 to 1, then this odd length substring will suddenly become an even length substring, which is of length 2. But then whatever was of even length will now become of odd length because it just has a single 0 now, right? So flipping a bit can actually change an odd length substring to even length substring and an even length substring to an odd length substring as well. Now if you think that again I will convert this odd length substring to even length, then you will be converting this 1 to 0. So what happened is you have converted this 0 to 1 and you have converted this 1 to 0. So yes, this is of even length, both ones. This is of even length, both zeros. But then this becomes of odd length. Now if you want to make this even length, then you will convert this 0 to 1 and this will be of even length again. Right. So in this way, we can note that odd length propagates until it meets another odd length substring. You see, when we met this substring 000 here, and when this one of the bit was converted to make the previous substring from odd to even, then this substring also became even length, right? From odd length it became even length. This is always true. I will show you more examples related to this. The third point is odd substring always exist in pair, right? Because the entire length of the string is even, and if you consider adding odd numbers to all the even numbers, then it will always be an odd number, right? So if you want to get the even number as the final answer, and if you are having a lot of even numbers already with one odd number, you must also have another odd number so as to balance. And odd plus odd will always become an even number. Otherwise you can keep on adding even with even, it will always be even, and even with odd will always be odd. So if you have an odd length substring, you will always have another odd length substring as a pair. Okay, because the entire length is guaranteed to be even. You can just think about it. Now the fourth point is very important, where it says that even substrings between the odd pairs will never be flipped. Let's look at the second example and try to understand this. In this example, the first substring was of odd length, then we have even length, then again an odd length. So these two are the odd length. Now in this case, if I want to make everything even, right, everything even, then what I do is I will flip this bit to 1. Then we have a substring both ones, and this will be of even length, right? And this bit becomes an odd length substring which is of length 1. So this even now becomes odd. Now in order to make this odd back to even again, then we have to flip this bit again to 0. So this will make 00 here, and that is how we will make this even. But then this will be converted to odd, the adjacent substring, right? In order to make this odd even again, we will be flipping the adjacent bit again to 1. So this becomes of even length, right? Now since this substring was already of odd length, now this substring is lost because all the zeros have vanished. So 0 length means even length. Okay, so this became of even length now. So the meaning of this is, whenever we have odd, even, odd, then the number of flips to make all these substring of even length will always be the number of even substrings in between the pair of odd substring. Okay, you can just think about it, take some few more examples. Now if I do the same, then I will not be able to do anything for this substring. It is already even, no need to do anything. It is already even, no need to do anything. But then whenever you find an odd substring, you will always have the odd substring in pair. There must be another odd substring to the right of it, so that if you convert this odd to even by doing a flip of bit, then this becomes of odd length, right? And then if you try to convert this to even length again by just doing a bit of the flip bit, then actually everyone will be converted to even length in between the two odd substring length. Okay, so this fourth point mentions that even substrings between the odd pairs will never be flipped. That means, what were the odd pairs? This was odd 1 substring, this was odd 2 substring, this was odd 3 substring, and this was odd 4 substring. So the flip happened between the odd 1 and odd 2 substring. The flip happened between odd 3 and odd 4 substring. But in between the odd 2 and odd 3 substring, there was no flip at all, and it will always be true. The flip always propagates from one odd substring to the next odd substring, and so everything in between will be made as even. Okay, and then another flipping operation will start once we find the third odd substring. Then another substring flips will start once I find the fifth odd substring. But in between the second and third, in between the fourth and fifth, there will be no flip at all. Okay, so this is an important observation for solving the problem. So if I am given a string and if I find out the type of substring length by just iterating over the string and just finding out what is the substring length, even, odd, and so on. Then I can easily find out the minimum operations by finding out the position of the pair of odd substring length. Let's say after converting the given string to even and odd length substring, I simply need to find out the number of even substring in between the two odd substrings. So if I find the odd 1 and odd 2 substring, then the gap in between them, which is 5 minus 1, 4, will be defining about 4 flips are required in order to make everything as even. And similarly, in the next odd pair, it will say that 10 minus 8, that means 2 flips will be required to make everything even. And that is why the minimum operations will be 6. This has been derived from all the observations and ideas that we have seen previously. Now we will be doing the dry run based on all the previous ideas and observations. Now in this case, I just need to find out what are the odd substrings. And if I can find them, then I can just calculate the gap between them to find out how many flips are required. Okay, so in order to do that, I need to also find out what are the substrings which are actually present. So here an odd length substring is present, then an even length, and then an odd length substring is present. So this will be marked as position 0, position 1, position 2, position 3. This means that the substring number 0 is odd, substring number 1 is even, substring number 2 is even, and substring number 3 is odd. So in this case, the minimum flips that are required will be 3 minus 0, which is 3 flips. Okay, so this is what I want to calculate as I had previously explained. So given the input string, I need to track the substring number of each of the odd length substring, and the substring number will be accounted for using the count variable. Whenever I go to a new substring, I will do count plus plus simply, right? The start and I pointer are actually used to find out the current substring. That means when the current substring is ending, the odd array will actually track the exact position of all the odd length substring. Okay, so this will be used to calculate our final result. Now let's say that our start will begin at index 0 and I will begin at start plus 1 all the time. Now I will continue my loop for I until I find that ith and I minus 1th index variables are not equal. So here 0 and 1 are not equal. So this is where I stop. What is the length of this substring? It is I minus start. So I minus start will always give you the length of substring, which is equals to 1 minus 0, which is 1 here. So 1 is an odd number. That means the first substring that you see is of odd length. So I will be tracking that the 0th number substring is odd length. And now since I am done with this substring, I will be going to the next substring. So I will be doing count plus plus. Now let's look at substring number 1. Now when I want to search for the new substring, then I will always be reassigning the start to I, and I will always be I plus plus, or you can say start plus 1. Okay, so I will be now starting at index 2 and checking with index 1. If it is equal, I will go to index 3, checking with index 2. It is not equal. What is the gap between this I and start? It is 2, which is 3 minus 1. So you see that when it is 2, then it is of even length, not odd length. So it will not be recorded into our odd substring. Okay, but this is the second substring and we are done with the substring. So I will be going to the next substring. So count plus plus for that, and the start position will be made as 3 and the I will be made as start plus 1, or you can say I plus plus. So this will be made as 4. So this will be your new I pointer and this will be your start. Now when I iterate, then I will be always checking the I with the I minus 1th value. If they are same, I will iterate. 5 is not equals to 4 because 0 is not equals to 1. So this is where I stop. Now what is the length of this substring? 5 minus 3, which is 2. Now 2 is again even length substring, so I will not be recording into my odd substrings. But then we are done with this substring, so I will be doing substring count plus plus, right? And then I will be starting a new substring. So new substring will start at index 5, which is I, and I will be made as I plus plus. So I will start from 6 and the start pointer will be here. Now again match this 6th with the 5th index. They are not matching, so we will stop. Again a substring has been extracted. What is the length? 6 minus 5, which is odd. It is 1. So since this is odd, therefore I can say that substring number 3 is odd. Okay, so I will be recording it into the odd length substrings. And since I am done with the current substring, I will be going to the next substring. And now the next substring will start at index 6 and the iteration will start at 7. So iteration start at 7, the start pointer is at 6. Now 7th and 6th are same, so go to the next item. 8th and 7th are not the same. So if they are not same, then I will stop here. My substring is done. What is the length? 8 minus 6, 2 which is even, so it will not be recorded. Again we are done with this substring, so I will be doing substring count plus plus. Now I will be starting a new substring at 8 and the iteration will start at 9. So iteration from 9 and the start from 8. Now check the 9th and the 8th character, they are same. Check 10th and 9th character, they are not the same. So that means we have to stop here. What is the length? 10 minus 8, it is 2 length, right? So it is even, so it will not be recorded. But then the substring has ended, so we will go to the new substring. Now in this case, the start point will be 10 and the I will be 11, right? So I will start here and this is the start. Now I and I minus 1 are not same, so this is where we stop. Again, this is of odd length, 11 minus 10 is 1. So this will be recorded. So the 6th substring is of odd length, right? So this is recorded. Now we will be going to the next substring. Our start point will be 11 and my iteration will start at 12. So this is my start point and this is my iteration start point. Now 12th, 11th are same, 13th, 12th are same, 14th, 13th are same, but 15th, 14th are not same. So this is where I stop. What is the length? 15 minus 11 is 4, which is of even length. So it will not get recorded, but we will go to the new substring, right? Therefore, I will be updating the start to 15 and I will be 16. Now this will be my start and this will be my I. Now since I am out of bound, my loop will break, and outside of the loop I have to check what is the length of the last substring. So this is 16 minus 15, which is of length 1. So this is of odd length, and that is why I have to record the count value here as well. So the odd array here says what is the position of each of the substring which are of odd length. You look at it. The first substring was odd, second was even, third was even, fourth was odd, fifth is even, sixth is even, seventh is odd, then eighth is even, and then the ninth is odd. Okay. So in this case the index was 0, 1, 2, 3, 4, 5, 6, 7, 8. So if you clearly look at it, the index number 0 and 3 were odd and this is recorded. Index number 6 and 8 are odd and this is also recorded. And according to our previous ideas, we know that the number of minimum flips required to make everything even between the two odd substring length is equals to the gap between them, which is 3 minus 0 here. So 3 minus 0 here, it will be 3 plus 8 minus 6 here, which will be 2. And we know that in between the second and the third odd length substring, if you have any even length substring, then this will not be touched. And it is always true in between the second and third odd length, in between the fourth and fifth odd length, and so on. So I can simply iterate over this odd length substring and I can find the result here. The answer will be equals to 5. Since we are iterating over this entire string exactly one time, therefore the time complexity is order of n, while the space complexity for the odd can be order of n, because all the substring can be of length 1 and they are alternating, right? So that can happen, and in the worst case I can store all the indices in the odd array. Let's now look at the code. If you are someone who is looking to prepare for top product based company within a limited time of just 3 months, then we have brought for you both the DSA and the system design live interview training program. The most important feature of this program is you get a filtered and condensed structured curriculum, in-depth discussion of all the topics, and my guarantee of your understanding, one-on-one guidance with me, and live weekend classes. To know more about the training, you can WhatsApp us on this given number. In this code we are given the string and I am taking the odd array and the size of the string. Now I am taking an iterator I. The start point of each of the substring will be pointed by the start. The count is actually the substring count. Now I will be starting my loop. So this is the entire loop structure. Inside each loop I will be skipping over all the items of the current substring until I keep on comparing the I with the I minus 1th value. If they are equal, I will keep on skipping that. So until I hit the end of the string, or my I and I minus 1th item are not equal, until then I will just keep on iterating. Okay. And if I break, then I will check what is the length of the window. That means what is the length of the substring. If it is odd, then I will be pushing the substring count into my odd array. And once that is done, then it does not matter whether we have seen an odd array or an even size array. I will always be starting a new substring count. So I will do count plus plus. And my new start point will be I, and I will be iterating from just the second index item of the current substring, which so I will have to do I plus plus. And I will keep on repeating unless I am done with parsing the entire string. And once I am done, I will be recording the last substring as well. So this is for accounting the last substring. If it is of odd length, then push the substring count value, otherwise you leave it. After having done that, I will just calculate the gap between O2 and O1 position, O4 and O3 position, and so on, right? So this is that which will calculate the minimum changes, and that I have to return. I hope you were able to understand this. If you still have any doubt, then feel free to comment below and I'll try to help you as soon as possible. Like and share our video and subscribe to our channel in order to watch more of these programming videos. See you guys in the next video. Thank you.